Welcome, ladies and gentlemen, to another edition of Binary Life. And today we'll solve another exercise, which is very interesting. It's the least larger number. So I've already solved it. I'll just do the walkthrough. It will be easy to understand. You don't need to worry about that. And I've copied, paste. This is the exercise here, the task. I've copied, pasted on above my code up here so that we can read together and understand. Alright, so let me just make the screen larger so that we can get through. So it says I'm given an integer of numbers, given an array of numbers as an index. Return either the index of the smallest number that is larger than the element and all the stuff. In fact, let's just do the example here. So this is an array that is given here, and we are given a particular index. This is index 0. What is that index 0? Is the number 4. So the answer is search for the numbers that are greater than 4. In this array, we can see that there are 2 of them. 5 and 6 is greater than 4. Now it says we should give the least larger one. Least larger, that's the name of the function. And the least larger of these 2 is 5 here. And what index does 5 belong to? Index is at index 3. That's the answer. So 0, 1, 2, 3. That's it. If you find it, you return that index. If you don't find it, return -1. So let's take this second example. We are given an array again here, the same array like the one up, but this time around we're given an index 4. What is at index 4? We have 1, 2, 3, 4. This is what is at index 4 here. Let's see, 1, 2, 0. No, sorry, it starts from 0 to 4. So what's an index 4 is this last number 6. 0, 1, 2, 3, 4. Alright, so how many numbers are greater than 6 here? We can say that there's none of them, so we'll just return -1. That's the scenario. So this is my function implemented here, and I have some additional 2 functions to make it easy. Let's just call it helper functions. So let's walk through, you see how they come into play. The first scenario is I get the index of the max. Index of the max is sort of like having the maximum index in an array. For example, this is for this array here, the largest number is 6 here. And what is the index of that number? 0, 1, 2, 3, 4. So we're going to have 4 here when the algorithm starts, if we execute with this array here. So this just get the maximum index. Why is that useful? That's useful for me because somewhere here, just at the beginning of the function, I'm going to check if the number that was given here matches the maximum one. If that's the case, there's no need to go through the loops below. I just return -1, because once we have found the largest number here, we don't need to look for another number greater than the largest one. So we just return -1. That is why this is very important. So if we find if the largest number was given, if the largest index was given here, when I do the comparison here, automatically I exit without using any of the helper functions below. Now this is another scenario here, which I discovered when I was passing my test cases at codewars, but I never anticipated this in the beginning. Now if all the elements in the array are identical, like let's say we have an array like this, 7, 7, 7. We can't find the least largest because no matter the 7 you pick, there's no number greater than 7. So for this particular scenario, we just return -1. So that is where this last helper functions come into play. If all the elements are identical, first of all, I check if the array is not empty. Like for this 7, 7 case, it's not empty. And then I compare. I use the every to loop through. I could also use a for loop like this. It works the same way. So I'll use an every that is going to compare every element of the array to the element of the array here, element here, to the first element out of 0. So I'll loop through a given array and I'll compare if every element matches the first one. If that's the case, every returns a boolean is going to return true or false. So if every element is identical, I return -1. And we are done with these 2 scenarios. Now the next for loop, this is where we enter into the pure logic of all of these workings inside here. So what do? I have to loop through this array. So right now I am here, actually I'm inside this for loop. So I have to loop through this array here. That is where my index idx, I do not want to conflate and mix it with this I that was given in the introduction. So this index loops through that array, and here I'm just trying to avoid the index that was given I. So for this particular scenario, when I'm looping, zero was given, zero index was given, so I want to what is at zero index? It is 4. I just want to forget about that 4 and concentrate on these other numbers. That is why I do a differentiation. So if it's different, if it's the same, it won't enter this loop, so we'll just quit. So if it's different, that's why I enter this loop, and I'm going to check if the number is greater than the store. And what's at the store? The store is, I took the number that was given. This is the largest, this is an index that was given, so I'm going to take the number and store somewhere. Like this is index 0, and what is that index? Index 0, it's 4, so I'll just store the 4 here. It's not obligatory, I just wanted to store so that I can be using it to do my comparisons. That's optional, and it's not optimal. It occupies extra memory space for using the store, but you get the point. I just wanted to make the algorithm very, very readable. So I'm going to make sure that it's greater than the store, because I'm looking for the least largest, every number that is bigger. So I'm going to compare if it's bigger than the store. If that's the case, I'm going to compare it with the larger number. Remember, this answer here had a larger number, like index of max. I'm going to make sure it's less than the max. If it's less than the max, I'm going to replace it. But this time around, not replacing the actual number, replacing the index here. All right. So that's the case. It's going to continually looping, and just keep changing this number until at the particular point we're going to have the least largest, and then we can just return it here. And that's all. And now this helper function returns the index of the maximum number, like I told you here. This is just a helper function to get the index of the biggest number in the array. So that's all. This is about everything I can share with you concerning this exercise. So I executed our test cases, everything is good, so I can submit. And then you see there are people that did it with one-liner which is not very readable, but it makes sense. This is another short one here. So this is the target. This functions like the store for us. So he filters the array here to get so that he will be left with the numbers that are bigger than the target. So he will be left with just the bigger numbers. So this makes it easy for him. And then when he gets the bigger numbers, he's going to take the minimum one. Like, I was very, very, very logical, but this is actually straightforward. So firstly, I store this number here, and then I filter my original array to make sure that I eliminate all the smaller numbers, so I'll be left with all the numbers that are bigger than the store. And then from the leftover, I'm going to take the minimum one, that will be the least largest. And then when I get that minimum one, I'm going to loop back the original array here. A is the original array, and get the index of, you see this find index. I'm going to get the index of this least large value. This is actually a clever solution. So find index, if you never knew there's a find index function. So I'm going to find an index of a number that is actually equivalent to the least largest. So this is actually the best readable and short form written algorithm. This is a little bit for some mature people. All right, so I'm going to stop here, and thanks for viewing, and see you on another video.